March 17, 1944, 28,000 feet above the Ruhr Valley, Lieutenant Klaus Mietusch of Jagdgeschwader 26 rolled his Focke-Wulf 190 into position behind what he assumed was another easy kill. The American fighter ahead looked like every other Republic P-47 Thunderbolt he'd seen. Fat, slow, ungainly. A flying milk jug, as the Luftwaffe pilots mockingly called them. Mietusch had 72 confirmed victories. He knew how to kill Allied fighters. He closed to 400 meters, the optimal range for his 4 20mm cannons and 2 13mm machine guns. His finger tightened on the trigger. Then the American pilot saw him. The Thunderbolt didn't try to turn. It didn't attempt to outmaneuver Mietusch's lighter, more agile Focke-Wulf. Instead, it rolled inverted and dove straight down, accelerating to speeds that Mietusch's fighter couldn't match. Within seconds, the P-47 had opened the distance to over 1,000 meters. Then it did something that changed Mietusch's understanding of air combat forever. The Thunderbolt pulled up hard from its dive, used its massive speed to climb back to altitude in seconds, and came around behind Mietusch before the German pilot could react. Mietusch broke hard right, trying to spiral away. He heard a sound like an industrial saw cutting through metal. A 2-second burst. The P-47's 850 caliber machine guns had fired approximately 200 rounds. 40 of those rounds found Mietusch's Focke-Wulf. His right wing separated from the fuselage. The aircraft tumbled into an uncontrollable spin. Klaus Mietusch managed to bail out, one of the few German pilots to survive an encounter with the weapon system that would redefine air superiority in World War II. When he was debriefed 3 days later after being captured by American ground forces, his report focused not on tactical errors or pilot skill, but on something the German High Command had not adequately appreciated: the sheer, overwhelming volume of fire that 8 synchronized 50 caliber machine guns could deliver in the span of a human heartbeat. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The mathematics were simple but terrifying. Each Browning M2 50 caliber machine gun, mounted in the P-47's wings, fired at approximately 450 to 575 rounds per minute, depending on maintenance and ammunition temperature. 8 guns meant a combined theoretical rate of fire between 3,600 and 4,600 rounds per minute. In practice, accounting for synchronization, timing, and the way different guns reached peak firing rate at slightly different moments, a well-maintained P-47 delivered approximately 4,800 rounds per minute when all 8 guns fired simultaneously. That translated to 80 rounds per second. A pilot holding the trigger for 10 seconds would expend 800 rounds of 50 caliber ammunition, but pilots never fired for 10 continuous seconds. They couldn't. The standard combat technique was the 2-second burst. In those 2 seconds, 160 rounds left the aircraft, converging on a target zone roughly 6 feet in diameter at the optimal combat range of 300 yards. Each 50 caliber round carried specifications that made it effective against both aerial and ground targets. The standard M2 ball cartridge achieved a muzzle velocity of 2,910 feet per second. The projectile weighed 707 grains, approximately 1.5 ounces, and delivered 13,500 foot-pounds of muzzle energy. For comparison, a standard infantry rifle round carried roughly 2,500 foot-pounds. The 50 caliber delivered more than 5 times the kinetic energy. The armor-piercing incendiary rounds, designated M8 API, could penetrate 19 millimeters of steel armor at 500 meters. More importantly for air combat, they ignited fuel and ammunition upon penetration. The projectile contained a small incendiary charge that activated when it passed through the target, creating fires inside fuel tanks and ammunition bays. German fighter construction emphasized lightweight aluminum frames and minimal armor to maximize speed and maneuverability. The Focke-Wulf 190, considered the finest German fighter of the war's middle years, used aluminum alloy stressed skin construction with armor protection only around the pilot and critical engine components. When 50-caliber armor-piercing incendiary rounds struck these aircraft, the results were catastrophic. A single round penetrating a fuel tank would puncture the self-sealing bladder and ignite the high-octane aviation fuel inside. 2 or 3 rounds in the same area would overwhelm the self-sealing mechanism entirely, creating massive fuel fires. Rounds striking the engine would shatter cooling systems, sever oil lines, and destroy the complex supercharger mechanisms that German engines required to operate at high altitude. The wing structure, essential for maintaining control at high speeds, would fail completely if even 5 or 6 rounds struck the same wing spar. German pilots who survived encounters with P-47 fire described the experience in their post-war debriefings. Oberleutnant Heinz Knoke, who flew 192 combat missions and survived the war, wrote extensively about American firepower. His account, preserved in the Bundesarchiv Militärarchiv in Freiburg, described what happened when P-47 fire found a German fighter. You hear the impacts before you see them. The sound is like someone hitting the aircraft with a steel hammer multiple times per second. Then you see holes appearing in your wings, each hole the size of a man's thumb. The airplane doesn't gradually lose control. It simply comes apart. I watched my wingman's aircraft disintegrate when a Thunderbolt fired a burst. One moment he was flying in formation. The next, his right wing folded upward and his aircraft entered a flat spin. He never got out. The psychological impact of facing this volume of fire proved as significant as the physical destruction. German fighter doctrine emphasized precise gunnery. Luftwaffe pilots trained to close to optimal range, typically 200 to 400 meters, and fire short, accurate bursts from their cannons. The 20mm Mauser MG-151 cannon and 30mm Mk-108 cannon were devastatingly effective weapons. A single 20mm high-explosive shell could destroy a fighter's control surface. A 30mm shell could blow the tail off a heavy bomber. But these weapons required accuracy. German pilots learned to conserve ammunition, firing only when they had a clear shot at a vital area of the enemy aircraft. They trained extensively in deflection shooting, learning to aim ahead of a maneuvering target to compensate for the target's movement and the shell's time of flight. The Americans had adopted a completely different philosophy. Rather than training pilots to be precision marksmen, American doctrine emphasized overwhelming volume of fire. The reasoning was mathematical. A German pilot firing a 2-second burst from his 4 20mm cannons would fire approximately 16 shells. If his accuracy was excellent, perhaps 4 to 6 shells would hit the target. Each hit would likely cause serious damage. An American pilot firing a 2-second burst from 8 50-caliber machine guns would fire 160 rounds. Even if his accuracy was mediocre, 20 to 40 rounds would hit the target. Each round carried less explosive power than a 20mm shell, but 40-50 caliber hits would destroy any aircraft just as surely as 6 cannon hits, and the American pilot had enough ammunition for 17 such bursts. The German pilot might manage 8 to 10 bursts before exhausting his cannon ammunition. The P-47's ammunition capacity was staggering by European standards. Each of the 8 guns was belt-fed from ammunition boxes containing 425 rounds. Total ammunition load was 3,400 rounds. At the combat rate of fire, this provided approximately 42 seconds of continuous firing. No pilot ever fired continuously for 42 seconds. The standard combat technique was multiple 2-second bursts, allowing time between bursts to aim, assess results, and adjust fire. A P-47 pilot could fire 17 separate 2-second bursts before exhausting his ammunition. In practice, most combat missions ended with ammunition remaining in the guns. The design that enabled this firepower had begun in 1940 at the Republic Aviation Corporation facilities in Farmingdale, New York. Chief designer Alexander Kartveli received specifications from the United States Army Air Corps for a high-altitude interceptor fighter. The requirements were demanding. The aircraft needed to operate effectively at altitudes above 30,000 feet, where German bomber formations were expected to fly beyond the reach of existing Allied fighters. Kartvel's solution was radical. He designed the fighter around the largest, most powerful engine available, the Pratt & Whitney R2 1800 double Wasp radial engine, which produced 2,000 horsepower. To enable high-altitude operations, he added a General Electric turbo supercharger, a complex device that used exhaust gases to compress incoming air, maintaining engine power at altitudes where normally aspirated engines would suffocate. The turbo supercharger system added significant weight and complexity. The supercharger itself weighed several hundred pounds and required elaborate ducting to channel exhaust gases from the engine to the turbine wheel. Then, channel compressed air back to the engine. This ducting ran through the fuselage, occupying space that in other fighters would be used for fuel or ammunition. Kartveli solved the space problem by making the aircraft larger, much larger. The P-47's fuselage measured 40 feet 9 inches from propeller hub to tail. The wingspan stretched 40 feet 9 inches tip to tip. Empty weight was 9,900 pounds. Loaded for combat with pilot, ammunition, and fuel, the aircraft weighed 13,500 pounds. For comparison, the Focke-Wulf 190 weighed 7,000 pounds loaded. The Messerschmitt Bf 109 weighed 6,900 pounds. The Americans had built a fighter that weighed nearly twice as much as the aircraft it would fight. German intelligence analysts reviewing the P-47's specifications in late 1942 concluded that the Americans had fundamentally misunderstood fighter design. The aircraft was too heavy to dogfight effectively. Its wing loading, the ratio of weight to wing area, was higher than any existing fighter. It would be slow to accelerate and unable to turn with German fighters. These analysts were correct about the P-47's limitations. The aircraft could not outturn a Focke-Wulf 190 or Messerschmitt Bf 109 in a horizontal turning fight. It accelerated slowly from low speeds. Its rate of roll, how quickly it could bank from level flight to a steep turn, was adequate but not exceptional. What the German analysts failed to appreciate was that Kartveli had not designed the P-47 to fight like a European fighter. He had designed it to fight like an American one. The key to the P-47's effectiveness lay not in maneuverability, but in energy management. The massive engine and turbo supercharger gave the P-47 exceptional performance at high altitude. At 30,000 feet, where German engines struggled for oxygen and produced reduced power, the P-47's turbocharged engine maintained near sea-level performance. This meant that while German fighters could barely climb above 25,000 feet, P-47 seconds operated comfortably at 30,000 feet and could reach 35,000 feet when necessary. From these altitudes, P-47 pilots would dive on German formations below. In the dive, the P-47's weight became an advantage rather than a liability. The heavy aircraft accelerated rapidly, reaching speeds in excess of 500 miles per hour. At these speeds, German fighters attempting to pursue would reach their structural limits and risk breaking apart from aerodynamic stress. The Americans called this tactic boom and zoom: spot the enemy from high altitude, dive at high speed, fire a burst, use the speed from the dive to climb back to altitude before the enemy could respond. Repeat. The tactic negated the German advantages in turning performance and eliminated the P-47's disadvantages in maneuverability. But none of these tactical advantages would matter if the P-47 couldn't survive combat damage. This was where Kartveli's design proved most revolutionary. He had built the aircraft to absorb punishment that would destroy any German fighter. The radial engine configuration placed 18 cylinders in a circular arrangement around the crankshaft. If enemy fire destroyed 1 or 2 cylinders, the remaining cylinders continued to produce power. German inline engines, by contrast, used cylinders arranged in a V configuration cooled by a liquid cooling system. A single round puncturing the cooling system would cause the engine to overheat and fail within minutes. The P-47's air-cooled engine had no vulnerable cooling system. Pilots could lose multiple cylinders, have the cowling shot away, and still fly hundreds of miles back to base. The aircraft's size provided another form of protection. The large fuselage meant that critical components, the pilot, engine, flight controls, were separated by several feet of space filled with non-essential structure. A round that might pass through a German fighter and hit multiple vital systems would punch through empty space in a P-47. Lieutenant Robert Johnson of the 61st Fighter Squadron, 56th Fighter Group, discovered the aircraft's durability on June 26, 1943, during a bomber escort mission over France. German fighters attacked his flight near the town of Saint-Omer. Johnson became separated from his squadron and found himself alone against multiple Focke-Wulf 190s. The German pilots pressed their attacks, firing repeatedly. Johnson's aircraft absorbed over 200 strikes from 20mm cannon shells and 13mm machine gun bullets. The rudder was destroyed. The elevator controls were damaged. Hydraulic fluid streamed from severed lines. The canopy jammed shut. Johnson couldn't bail out, even if he wanted to. One German pilot emptied his ammunition at Johnson's crippled P-47, then flew alongside, apparently, unable to believe the American aircraft was still flying. According to Johnson's later account, the German pilot shook his head, gave what might have been a salute, and departed, perhaps returning to base to report this strange, indestructible American fighter. Johnson flew his destroyed P-47 across the English Channel and crash-landed at an RAF base in southern England. The aircraft was so badly damaged that it was written off as a total loss. Johnson walked away without serious injury. The story spread rapidly through the 8th Air Force fighter groups based in England. If a P-47 could survive 200 hits and bring its pilot home, perhaps this ugly, heavy fighter was exactly what they needed. German pilots, hearing the same story, reached different conclusions. If 200 hits could not destroy a P-47, what hope did they have? Their ammunition capacity was limited. Their accuracy, even among experienced pilots, meant that perhaps 1 in 10 rounds fired would strike the target. Against an aircraft that could absorb 200 hits and survive, the mathematics of air combat had shifted decisively against them. The spring of 1943 brought the first large-scale P-47 operations over occupied Europe. The 56th Fighter Group, 78th Fighter Group, and 4th Fighter Group, equipped with Thunderbolts, began flying bomber escort missions into France and the Low Countries. German fighter units scrambled to intercept, confident in their aircraft and their skills. The initial encounters were confused and inconclusive. P-47 pilots, new to combat, made tactical errors. They tried to dogfight with German fighters, playing to their opponent's strengths. German pilots shot down several P-47 seconds and reported that the new American fighter, while tough, was too slow and heavy to be a serious threat. Then American pilots learned how to use their aircraft properly. The transformation came quickly. By July 1943, just 3 months after large-scale operations began, P-47 units had refined their tactics and begun to achieve kill ratios that shocked the Luftwaffe. The key was discipline. P-47 pilots learned never to let themselves be drawn into turning fights where German aircraft held the advantage. Instead, they maintained altitude advantage, dove on German formations at high speed, fired their devastating 8-gun bursts, and used their speed to climb back to safety. If German fighters pursued them upward, the P-47's superior high-altitude performance gave American pilots the advantage. If German fighters didn't pursue, American pilots simply repeated the attack. The effectiveness of the 8-gun armament became apparent in combat reports filed by both American and German pilots. Captain Gerald Johnson of the 56th Fighter Group engaged a Messerschmitt Bf 109 over Holland on August 19, 1943. His combat report, preserved in the National Archives, described the engagement with clinical precision. Closed to 300 yards, fired 2-second burst, observed strikes along fuselage and wing route. Enemy aircraft rolled left and entered inverted dive. Pieces separated from aircraft, no parachute observed. Engagement duration from first shot to enemy aircraft destruction, approximately 4 seconds. 4 seconds. 160 rounds fired. Target destroyed. This was the new reality of air combat over Europe. German aircraft that had been carefully designed, expensively manufactured, and flown by trained pilots could be destroyed in less time than it took to read this sentence. Hans Philipp, one of Germany's most skilled and experienced fighter pilots, a man who had survived hundreds of combat missions against overwhelming odds, died in less time than it took to read his obituary. The 850 caliber machine guns had fired their verdict, and no amount of skill or courage could change the outcome. The loss of pilots like Philipp had strategic consequences that extended far beyond the tactical. Germany's fighter pilot training program, already strained by fuel shortages and the need to defend against round-the-clock Allied bombing, could not replace experienced pilots quickly enough. New pilots arrived at frontline units with less than 100 hours of total flight time. Many had never fired their guns at a moving target before their first combat mission. American pilots, by contrast, received training that exceeded 400 hours before deployment to combat units. They practiced gunnery extensively, firing thousands of rounds at towed targets and ground targets. They learned aerobatics, formation flying, navigation, and instrument flying. By the time they reached their first combat mission, they had internalized the basics and could focus on tactics and survival. The disparity in training quality showed immediately in combat results. An experienced German pilot might achieve a few victories before being shot down or killed. An American pilot with proper training might survive his entire tour of duty and return home. The mathematics were unforgiving. Germany was losing its experienced pilots faster than new ones could gain experience. America was building a force of increasingly skilled pilots, backed by overwhelming material superiority. The 850 caliber machine guns played a central role in this dynamic. The volume of fire they delivered meant that American pilots didn't need to be expert marksmen to achieve kills. A mediocre shot who could position his aircraft properly and fire a 3-second burst would likely destroy his target simply through the overwhelming number of rounds in the air. A German pilot needed to be an excellent shot because his limited ammunition meant every burst had to count. By summer 1944, as Allied forces landed in Normandy and began the liberation of France, P-47 seconds transitioned from pure air superiority missions to ground attack operations. The P-51 Mustang, with its longer range and lighter weight, took over bomber escort duties. The P-47, with its superior ability to absorb ground fire and its devastating firepower, became the premier fighter bomber in the Allied arsenal. The 850 caliber machine guns proved equally effective against ground targets. A single strafing pass by a P-47 could destroy trucks, trains, armored vehicles, artillery positions, and troop concentrations. The standard attack profile called for a shallow dive from about 5,000 feet, opening fire at 800 yards and continuing until pulling up at about 200 yards from the target. During this firing pass, a pilot might fire a 4 to 6 second burst, expending 320 to 480 rounds. At the typical strafing distance, these rounds would impact in a zone approximately 50 feet long and 10 feet wide. Everything in that zone would be destroyed or severely damaged. Trucks would explode as 50 caliber rounds penetrated fuel, tanks, and ignited gasoline. Armored vehicles would be penetrated if struck at the proper angle, the armor-piercing incendiary rounds having sufficient energy to defeat the light armor used on German half-tracks and armored cars. German soldiers who survived P-47 strafing attacks described the experience in their post-war interviews. Oberleutnant Hans Schmidt of the 352nd Infantry Division survived multiple strafing attacks during the retreat from Normandy in August 1944. His account, recorded by American interrogators, captured the helplessness German ground forces felt. "You hear the engine sound first. It's a distinctive deep roar from the big radial engine. You have perhaps 3 or 4 seconds to find cover. Then you hear the guns. Not individual shots, but a continuous tearing sound, like heavy cloth being ripped. The bullets hit everything. Stone walls explode. Trees are cut in half. Metal vehicles simply come apart. I watched a supply truck take a direct burst. The truck existed one moment and was gone the next. Just burning pieces scattered across the road. The gunfire lasts only a few seconds, but it feels much longer. Then the plane pulls up and you realize you're still alive. But you know he's coming back, and there are more planes behind him. The psychological effect of this firepower on German ground forces was cumulative and severe. German soldiers developed what military psychologists called Jabbo fever, or fighter-bomber fever, a form of combat stress specifically associated with fear of air attack. Symptoms included reluctance to move during daylight hours, extreme startle response to aircraft engine sounds, and in severe cases, complete breakdown of combat effectiveness. German unit commanders reported that by late 1944, entire companies would refuse to move during daylight, even when no aircraft were visible. The knowledge that P-47 seconds and other Allied fighter bombers controlled the skies meant that any movement could draw immediate attack. This paralysis had strategic consequences. German forces could not maneuver effectively, could not concentrate for counterattacks, and could not sustain defensive operations when their supply lines were interdicted by constant air attack. The numbers tell the story of this air dominance. Between D-Day on June 6, 1944, and the German surrender on May 8, 1945, P-47 seconds destroyed or damaged 9,000 locomotives, 86,000 railroad cars, 6,000 armoured vehicles, and 68,000 trucks. These were not estimates. These were confirmed kills verified by gun camera footage and ground reconnaissance. The destruction of this equipment had cascading effects on German military operations. Locomotives destroyed meant trains couldn't move ammunition, fuel, and reinforcements. Trucks destroyed meant supplies couldn't reach frontline units. Armoured vehicles destroyed meant German mechanized forces couldn't execute the mobile warfare doctrine they had perfected earlier in the war. The 850 caliber machine guns, multiplied across hundreds of P-47 seconds flying dozens of sorties per day, had effectively paralyzed German logistics. The effectiveness of the P-47's ground attack capability came not just from the 8 machine guns, though these were formidable, but from the aircraft's ability to carry additional ordnance. A typical P-47 ground attack loadout included 2,000 pounds of bombs, either 2 1,000-pound bombs or 4 500-pound bombs, plus 8 5-inch high-velocity aircraft rockets. The rockets, designated HVAR for high-velocity aircraft rocket, carried warheads comparable to 5-inch naval artillery shells. A direct hit from an HVAR could destroy a tank, demolish a building, or crater a runway. P-47 pilots would typically use their rockets and bombs against hardened targets like bunkers, bridges, and armoured vehicles, then use their machine guns against softer targets like trucks, troops, and equipment. This combination of heavy bombs, powerful rockets, and 850 caliber machine guns made the P-47 the most versatile and deadly ground attack aircraft in the Allied inventory. German forces learned to fear the distinctive silhouette of the P-47, recognizing it immediately and taking cover whenever one appeared. The psychological impact of this instant recognition cannot be overstated. German soldiers knew what was coming. They understood the capabilities of the weapon system attacking them, and they knew there was very little they could do to defend themselves effectively. German anti-aircraft defences, which had been formidable earlier in the war, proved increasingly ineffective against P-47 seconds. The aircraft's rugged construction meant it could sustain significant anti-aircraft damage and continue its mission. Pilots reported returning to base with flak damage that had severed control cables, punctured fuel tanks, and destroyed entire sections of wing or tail structure, yet the aircraft continued to fly. The radial engine's resistance to damage played a crucial role in this survivability. Light anti-aircraft fire, typically 20mm or 37mm guns, would need to achieve multiple direct hits on the engine to stop it. Even then, the P-47 might remain flyable long enough for the pilot to reach friendly territory. Heavier anti-aircraft fire from 88mm guns could destroy a P-47 with a single hit, but these weapons had difficulty tracking fast-moving aircraft and fired slowly, perhaps 15 to 20 rounds per minute. The net result was that German anti-aircraft defences, facing hundreds of Allied aircraft daily, could not inflict sufficient casualties to deter or significantly reduce Allied air operations. P-47 units typically lost 1 to 3% of aircraft per mission to all causes, including anti-aircraft fire, mechanical failure, and enemy fighters. This loss rate was sustainable, given American production capacity and pilot training throughput. German losses, by contrast, were not sustainable. Luftwaffe fighter units facing American fighter sweeps and bomber escort missions lost 5 to 10% of their aircraft per mission by late 1944. At this attrition rate, a fighter unit would be completely destroyed within 10 to 20 missions. New aircraft and pilots could replace losses, but the new pilots had minimal training and little chance of survival against experienced American pilots flying superior aircraft. The final months of the war saw the complete collapse of German air resistance over Western Europe. By March 1945, Luftwaffe fighter units had largely ceased attempting to intercept American bomber formations. The few fighters that did scramble were quickly shot down by escorting P-47 seconds and P-51 seconds. German fighters began to be seen so rarely that American bomber crews sometimes flew entire missions without encountering enemy aircraft. This air supremacy allowed P-47 seconds to operate with near impunity against ground targets. Entire fighter groups would patrol assigned sectors, attacking anything that moved. German forces abandoned attempts to move during daylight. Supply convoys moved only at night. Troop movements occurred under cover of darkness. Tanks and armoured vehicles were hidden in forests and buildings during the day, but night movement brought its own problems. Navigation was difficult. Units became separated. Supply convoys took hours longer to reach their destinations. The cumulative effect was that German military operations slowed to a pace that made effective resistance impossible. American and British ground forces advanced steadily, supported by air power that German forces could not counter. The statistics of P-47 operations in the final year of the war tell the story of complete air dominance. The 56th Fighter Group, one of the highest-scoring P-47 units, claimed 674.5 aerial victories and destroyed over 300 German aircraft on the ground. The group flew over 18,000 sorties and lost 128 aircraft in combat. The kill-to-loss ratio exceeded 5, 1 inch the air and 2 to 1 when including ground losses. These numbers, multiplied across the 15 P-47 groups that served in the European theatre, represent the destruction of Germany's ability to contest control of the air, and at the heart of this destruction was the weapon system that Klaus Mietusch had encountered on March 17, 1944, 8 Browning 50 caliber machine guns, synchronized to fire 80 rounds per second, capable of sawing an aircraft in half in the time it took to draw a breath. Part 3. The technical specifications that enabled this devastation were remarkable for their simplicity and reliability. Each Browning M 250 caliber machine gun weighed 64 pounds. 8 guns added 512 pounds to the aircraft. The ammunition, 3,400 rounds at approximately 1 pound per 5 rounds, added another 680 pounds. Total armament weight was approximately 1,200 pounds, roughly 9% of the P-47's loaded weight. This weight penalty was substantial but acceptable given the firepower it provided. German fighters typically carried lighter armament, perhaps 400 pounds total for guns and ammunition, but this lighter weight didn't translate to superior performance because German aircraft were also structurally lighter and less capable of absorbing battle damage. The 8 guns were arranged in 2 banks of 4, with 4 guns in each wing outboard of the propeller arc. This arrangement required careful harmonization to ensure all 8 guns converged at the same point. Armourers would adjust each gun mount so the gun's bore pointed slightly inward. When all 8 guns were properly harmonized, Their fire would converge at approximately 300 yards from the aircraft. At this convergence point, the 8 streams of bullets would create a pattern roughly 6 feet in diameter. Inside this pattern, the density of fire was so great that anything struck would be destroyed. A human body hit by even a single 50 caliber round would suffer catastrophic trauma. An aircraft structure hit by 20 or 30 rounds in a concentrated area would simply disintegrate. The reliability of the M2 Browning was legendary. The weapon had been designed by John Moses Browning, whose firearms designs dominated American military arsenals from the 1892 through World War II. Browning had died in 1926, but his final machine gun design would serve for the next century. The M2's operating principle was simple recoil operation with a short recoil stroke. When the gun fired, the barrel and bolt recoiled together for a short distance, perhaps half an inch. At the end of this recoil stroke, the bolt unlocked from the barrel stopped moving, and the bolt continued rearward, extracting the spent cartridge case. A powerful recoil spring then drove the bolt forward, chambering a new round and locking the bolt to the barrel. The cycle repeated at a rate of approximately 450 to 575 rounds per minute, depending on numerous factors, including ammunition, temperature, lubrication, and maintenance condition. This relatively slow rate of fire, compared to weapons like the German MG-42, which fired at 1,200 rounds per minute, was actually an advantage for the M2. The slower rate meant less barrel heating, less ammunition consumption, and more controllable fire. A P-47 pilot could fire multiple 2-second bursts without overheating his guns. An MG-42 gunner firing equivalent bursts would quickly overheat his barrel and require a barrel change, a procedure that took trained gunners approximately 5 to 10 seconds under ideal conditions. The M2's reputation for reliability came from extensive testing during development and from combat experience across multiple wars. The gun functioned in temperatures from -40 degrees Fahrenheit to +120 degrees Fahrenheit. It operated at altitudes from sea level to 40,000 feet. It continued firing after being exposed to sand, mud, salt water, and general abuse that would disable more delicate weapons. P-47 pilots reported instances of guns continuing to fire after being hit by German cannon shells. The robust construction and simple operating principle meant that even damaged guns often continued to function long enough to complete the mission. This reliability was not accidental. American ordnance engineers had conducted exhaustive testing during weapon development. Guns were fired until they failed, then examined to determine the cause of failure. Design improvements eliminated failure modes. The process repeated until the weapon achieved reliability standards that exceeded requirements. The ammunition system was equally robust. The 50 caliber Browning machine gun cartridge used a rimless bottleneck design that fed reliably from disintegrating metal link belts. As each round was fired, the link holding it fell away, reducing the weight the feed system had to manage. This meant the feed system could be simpler and lighter than systems using non-disintegrating belts. The cartridge itself was a marvel of manufacturing precision. Each round consisted of a brass case approximately 3.91 inches long, a large rifle primer, approximately 240 grains of propellant powder, and a bullet weighing between 647 and 707 grains depending on type. The armor-piercing incendiary round used a hardened steel core surrounded by a thin jacket of gilding metal, a copper-zinc alloy. At the base of the bullet was a small cavity containing incendiary compound, typically a mixture that would ignite upon impact. Manufacturing these cartridges in the quantities required for the war effort represented a significant industrial achievement. American ammunition plants produced approximately 12 billion rounds of small arms ammunition during World War II. Of this total, approximately 3 billion rounds were 50 caliber, intended for both the M2 heavy machine gun and the various aircraft machine guns derived from it. The scale of this production can be difficult to comprehend. 3 billion rounds meant approximately 7 million rounds per day, every day, for 4 years. Each round required precision manufacturing to ensure reliable feeding and firing. Quality control procedures rejected cartridges that didn't meet specifications. The accepted ammunition was packaged in containers designed for long-term storage and rough handling, then shipped to combat theaters worldwide. This logistical achievement meant that American P-47 pilots never lacked ammunition. Missions were planned with full ammunition loads. Pilots were encouraged to fire liberally when engaging targets. There was no need to conserve ammunition because more would always be available. This mindset was completely foreign to German pilots who understood that ammunition was scarce and must be conserved for certain kills. The contrast in logistics philosophy extended beyond ammunition. American military doctrine emphasized overwhelming material superiority as the foundation of success. Logistics units were trained to maintain supply flow even under difficult conditions. Supply lines stretched from American factories across the Atlantic Ocean to bases in England, then forward to operational airfields in France and eventually Germany. This supply chain moved not just ammunition but spare parts, replacement engines, tires, instruments, radios, and the countless other items required to keep a modern air force operational. When a P-47 returned from a mission with battle damage, ground crews could typically repair it within hours or days using spare parts from supply. When a German fighter returned with similar damage, it might wait weeks for parts that never arrived. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The human cost of facing the 8-gun armament manifested in the steadily declining experience level of Luftwaffe fighter pilots. In early 1943, the average German fighter pilot had several hundred hours of experience, and often multiple victories. By early 1945, new pilots arrived at units with less than 100 hours total flight time and no combat experience. These inexperienced pilots faced American pilots with 400-plus hours of training and often 6 months to a year of combat experience. The outcome of such encounters was predictable. German pilots who survived their first few missions might gain enough experience to become effective. Most didn't survive. The average combat life expectancy of a new German fighter pilot by early 1945 was measured in hours of flight time, often less than 10 hours before being killed or severely wounded. American pilots, while certainly not immune to combat losses, had far better survival prospects. Comprehensive training meant they understood basic tactics and aircraft handling before their first combat mission. The superior performance of the P-47 meant they could disengage from unfavorable combat situations. The 850 caliber machine guns meant that when they did get a shot, it was likely to be lethal. General Lieutenant Adolf Galland, who commanded all German fighter forces from late 1941 through early 1945, wrote extensively after the war about the factors that led to Germany's defeat in the air. His analysis, published in his memoir The First and the Last, included frank assessment of American aircraft and tactics. Galland noted that while the Messerschmitt Me 262 jet fighter was superior to any Allied aircraft in performance, it arrived too late and in too few numbers to affect the outcome. Even if Germany had produced the Me 262 earlier, Galland questioned whether it would have made a strategic difference given the overwhelming numerical superiority Allied forces achieved by late 1944. Regarding the P-47 specifically, Galland wrote that German pilots initially underestimated the aircraft due to its appearance and performance in turning combat. Once American pilots learned to use the P-47's strengths, diving speed and high-altitude performance, it became a formidable opponent. The 8 machine guns gave even inexperienced American pilots the ability to destroy German aircraft if they could achieve firing position. Galland's assessment, based on his experience commanding the entire German fighter force, confirmed what individual pilots had learned through bitter experience. The P-47 and its 8-gun armament represented a different philosophy of air combat, one based on overwhelming firepower rather than dogfighting finesse. In the industrial total war that World War II had become, the American approach proved decisive. The final aerial victory credited to P-47 seconds occurred on May 8, 1945, the day Germany surrendered. A flight of P-47 seconds from the 362nd Fighter Group encountered and shot down two German Fieseler 156 Storch observation aircraft attempting to flee to neutral Sweden. These were the last German aircraft destroyed in combat over Europe in World War II. The engagement lasted seconds, a brief burst from 8 synchronized machine guns, and the war in the air was over. The total aerial victory count for P-47 seconds reached 3,752 confirmed kills of German aircraft. An additional 3,315 German aircraft were destroyed on the ground by P-47 strafing attacks. These numbers don't include thousands of locomotives, vehicles, and other ground targets destroyed in the final year of the war. The 850 caliber machine guns had inscribed their verdict across the skies of Europe in letters written in tracer fire and wreckage. In the decades after the war, military historians and aviation enthusiasts debated which World War II fighter was best. The P-51 Mustang received praise for its long range and elegant lines. The F-4U Corsair was celebrated for its service in the Pacific. The British Spitfire achieved iconic status in popular culture, but measured by total victories, ground kills, and sustained combat operations, the P-47 Thunderbolt achieved results that exceeded all competitors. More than 15,600 P-47 seconds were built, making it the most produced American fighter of World War II. The aircraft served not just with American forces, but with British, French, Soviet, Brazilian, and Mexican air forces. It remained in service with some air forces into the 1950s, long after more modern jets had replaced it in frontline American units. This longevity testified to the soundness of Alexander Kartvel's design and the effectiveness of the 8-gun armament concept. The lasting legacy of the P-47's firepower can be measured in how it influenced post-war fighter design. The concept of multiple machine guns, arranged in wings, became standard practice. Even as cannon armament became more common in jet fighters, the principle remained. Overwhelming volume of fire delivered by multiple weapons was more effective than single powerful weapons with limited ammunition. The M2 Browning 50 caliber machine gun itself remained in service far longer than the P-47. The weapon continues to serve in the 21st century, more than 90 years after its initial development. It equips vehicles, helicopters, and naval vessels. It serves as the standard heavy machine gun for American forces and many allied nations. No weapon system in history has enjoyed such extended service life while maintaining effectiveness across such varied roles. For the German pilots who faced the 8-gun armament in World War II, the P-47 became a symbol of American industrial might and the futility of Germany's war effort. Klaus Mietusch, who survived his encounter with a P-47 inches March 1944, spent the remainder of the war in a prisoner camp. After his release, he was interviewed by American intelligence officers, gathering information on German perspectives of American equipment. His assessment was simple and devastating. When I first saw the Thunderbolt, I thought the Americans had built a fighter for cargo pilots who didn't understand air combat. After I fought them, I understood that they had built exactly what they needed. A plane that could take incredible punishment, climb to heights where our fighters couldn't follow, dive at speeds we couldn't match, and fire enough ammunition to destroy anything they hit. We laughed at them in 1943. By 1944, we feared them. By 1945, we simply tried to avoid them. The 850 caliber machine guns that fired 800 rounds in 10 seconds had delivered their verdict on aerial warfare, not through elegant dogfighting or tactical sophistication, but through simple, overwhelming, industrial firepower. The German pilots' transformation from mockery to terror took less than 2 years. The sound of those 8 guns firing in unison became the sound of inevitability, each burst a reminder that industrial capacity, reliable weapons, and adequate training would always triumph over sophisticated designs produced in insufficient quantities. The thunder of the P-47's guns fell silent in May 1945, but their echo continues through military aviation history. They proved that sometimes the most effective weapon is not the most sophisticated, but the one that appears in overwhelming numbers, works reliably every time, and delivers firepower that no opponent can withstand. 8 guns, 800 rounds in 10 seconds. And air superiority that would never be challenged again.